Hello friends, welcome back to my YouTube channel. So in last video we have seen the degree of freedom for beams with considering the axial deformation. We have seen in my previous video. So with considering the axial deformation, and we also solved some problems on that. In exams, if they say find the decay with considering the axial deformation, we have to do in this method by using this formula. By using manually, I have shown how to calculate by manually as well as using this formula. You can go through that video. So and sometimes they'll say find the decay with neglecting the axial deformation. Today I will show how to find the decay without considering the axial deformation. So this is the formula for decay with neglecting the axial deformation. So formula is decay is equal to 2j minus r plus ec. So this formula, so how it comes I will show. So in previous video I have shown if you take any joint. So if you take any joint, suppose this is the hinge, this is the fix. If you take any joint, the possible way of deformation will be three. One is horizontal and vertical deformation, and one moment is there. So I have explained in my previous video the possible way of deformation is one is axial deformation. This is also called as the horizontal. Horizontal deformation and vertical deformation, and one moment will be there. The possible deformation at a joint is three: axial, vertical and moment. So here what they have mentioned, find the decay with neglecting the axial deformation. It means the number of deformation is 3. So they said to neglect the axial deformation. It means we should not consider axial deformation. We have to neglect axial deformation here. So how many deformation are there? 1 and 2. That's why in our formula there is 2 into j. At a joint there is only 2 deformation. With neglecting the axial deformation, the remaining is 2. That's why I have taken 2 into j. At joint there will be 2 deformations. One is vertical and one is moment. So that I have taken here 2 into j. So in case of with considering the axial deformation, so our formula is, I will show you, our formula is 3 into j here. Here they said to consider the axial deformation. It means we have to consider these two, axial deformation and moment and vertical. So in this formula 3 into j, at a joint we have to take the 3 deformation. So that in here 3 into j, we have to take here 3j. So here they said to neglect the axial deformation. That's why we are neglecting axial deformation. So our remaining deformation is 2 at a joint. That's why I have written here 2 into j. So this is the formula. We have to calculate decay by using this formula. I will show how to calculate by manual and as usual by using this formula. So if I, for example, if I take a beam, one end is hinged and other is fixed. Drawing again this joint to here. At joint usually 3 deformation will take place. So in our hinge there will be 2 reaction, one is horizontal and one is vertical. So in our problem, so in our topic what they have said, we have to calculate the decay by neglecting the axial deformation. It means we have to neglect the axial deformation here and as well as here we have to neglect. We should not consider the axial deformation. So that I am neglecting here and here in deformation as well as reaction. So remaining how many 1, 2, 3. One is vertical force is there and one moment is there. So here also vertical force is there, here also vertical force is there. So again both will get cancelled. Though here is rotation is there, at in support there is no rotation. So degree of decay at inch is 1. Or in support cannot resist a moment, so that our decay value is 1 at in support. So when it comes to fixed support, our reaction is 3. One is horizontal, vertical and moment is there. The at this joint the possible deformation is horizontal, vertical and moment. So here we have to neglect the again horizontal. So we should not count this. So I am erasing it. So here also vertical deformation is there and vertical reaction, both will get cancelled with each other, and one moment is there. Here also rotation is there, both will get cancelled each other. So at fixed support our decay is 0. So this is how we calculate the decay with neglecting the axial deformation. So if you, with the help of this formula also we will see. So as usual our J is the joint, J is the number of joints and R is the unknowns or reactions, number of reactions. Our EC is the number of inches, number of internal inch. So substitute in this formula. So decay is 2. How many joints? 1, 2. Joint is 2. And how many? So how many unknown reactions? Here 1, here 1, 2. Total 3. We should not consider the horizontal one. So there is no internal inch, so our EC is 0. 2 2 is 4. 4 minus 3, 1. So decay is 1. So here also how many numbers of decay? Only 1. 1 plus 0, 1. So decay is, when we calculate manually our decay value will come out as 1. When you calculate with the help of this formula, so our decay value will come out as 1. This is how we calculate the decay with neglecting the axial deformation. So I will solve some problems on this. I will show as well as manually, and with the help of this formula 2j minus r into EC, I will show how to calculate. In both ways I will show. I have taken one joint here, I have taken one structure here. So this is the beam. So at fixed, first I will, with the help of this formula we will calculate first. Now formula J is there, so how many joints? 1 2 3, 3 joints. How many unknowns? Here 2. One is vertical, one is movement. We have to neglect the horizontal. At internal inch there is no. Here also at inch there is 2. Horizontal and vertical we have to neglect the vertical. We have to neglect the horizontal. That's why I am taking only vertical reaction. So how many unknowns? 1 2 3. How many unknowns? 3. And EC is there. EC is m dash minus 1 formula. So m dash is the member. How many members connected to the internal edge? 1 2 members. So 2 minus 1 is 1. So now substitute in our formula. So dk is equal to, our formula is 2 into j. 2 into j minus r plus EC. This is our formula. So 2 into j is 3 minus r is 3 plus EC is 1. 2 into 3, 6 minus 3 plus 1 minus 2. The answer will come out as 4. So dk is 4. If we move to this beam, this is the How many numbers of joints are there? 1, 2, 3, 4, 4. How many numbers of reaction? Here in support, only one that will come. Vertical, here also vertical is only, there is at roller support, there is only one reaction will come. Here also one come. So 1, 1, 1, 1 plus 1, 2, 2 plus 1, 3. Total numbers of unknowns are 3. So how many internal links? Internal links, there is only one internal is. 2 members are connected to this internal is. 2 minus 1 is 1 again. So now substitute in our formula. dk is equal to 2 into j is 4 minus r is 3 plus ec is 1. 2 into 4, 8. Minus 2 plus 1 minus 2. 8 minus 2, 6. So our dk, it will come out as 6. We will move to this. How many joints are there? 1, 2, 3, 4. How many unknowns? Here 2 comes, here 1, here 2. Total number of reactions are 5. EC again, it will come out as 1, 2 minus 1, 2 minus 1, 1. So now substitute in our formula. dk is equal to 2 into joint is 4. Joint is 4 minus our unknowns are 5 plus 1. 2 into 4. 2 into 4, 8 minus 5 plus 1 minus 4. So 8 minus 4, 4. So our dk will come out as 4. Here also, how many joints are there? 1, 2, 3, 4. Number of joints are 4. So how many reactions are there? Here 2, here 1, 1. Total numbers of unknowns are 4. Our EC is again 1. There is only one internal is. 2 minus 1 is 1. So now substitute in our formula. dk is, so dk is equal to 2 into j is 4 minus unknowns are 4 plus EC is 1. 2 into 4, 8 minus 4 plus 3 minus 3. It will come out as 5. So dk is 5. If you go with this, so this don't get confused here. They have given your UDL and 2 points load. So in our problem, what we have to need is only joints, unknowns, and is there any internal hinge? So there is no interest, or EC value is 0. How many joints? 1, 2, 3, 4. Number of joints are 4. How many unknowns? Here 2, here 1, here 1, here 1. Total numbers of unknowns are 6. We have to do nothing with this UDL and 2 points load. Don't get confused here. They gave this to confuse you. So our joints is 2 into j is 4 minus r is 6 plus EC is 0. 2 into 4, 8. 8 minus 6, it will come out as 2. So our DC value is 2. So here, how many joints? 1, 2, 3, 4. 4 joints. How many unknowns? Here 2 will come, here 2, here 2, here 2. 4 into internal hinge. So we have to do 2 times here. So it is called as EC1, EC2. So EC1, how many members are connected to this hinge? This hinge 2. 2 minus 1 is 1. And EC2, how many members are connected? 2. 2 minus 1 is 1. So now calculate the EC is equal to EC1 plus EC2. EC1 is 1. EC2 is 2. 1 plus 1, 2. So EC value is 2. Now substitute in our formula. dk is equal to 2 into joints are 4 minus reactions are 4. And this is 2. E is 2. This is 2. 2 into 4, 8. minus 4 plus 2, 2. So 8 minus 2, 6. So dk will come out as 6. So now we'll see. We'll take the structure. So how many joints are there? 1, 2, 3, 4, 5. 5 joints. How many unknown reactions? Here 1, here 2, here also 1. Total 1, 2, 3, 4. Total numbers unknowns are 4. Now this is one internal range. So 2 minus 1 is 1. So now substitute in our formula. dk is equal to 2 into 5 minus 4 plus 1. 2 into 5, 10 minus 4 plus 1, 3. So 10 minus 3 is 7. So dk will come out as 7. So this is how we calculate the dk by using the formula. Now we will see the how to calculate without the help of this formula. 2j minus r plus ec. Manually we will do. We'll start from 1. So we'll start from this. At fixed support, how many reactions are there? One is vertical and another is one moment will come, one is horizontal. So we are not considering horizontal, so that only 2 reactions will come. So here, so 2 reactions will come. So at this fixed end, at this joint, so how many deformation, the possible deformation, one is moment, one is vertical. So horizontal we are not considering. So now what happens? Here also vertical force is there and vertical deformation is there. Both will get cancelled each other. Here also one rotation is there. Here also rotation is there. Both will get cancelled at this fixed joint. So when it comes to hinge, there the rotation takes in this direction, anti-clockwise and clockwise and anti-clockwise direction. The deformation will take place at the internal hinge, and one more deformation, vertical deformation will take place. Total numbers of deformation at internal hinge is 3. Since we are not considering since we have to neglect the horizontal deformation, so that total number of dk at internal hinge is 3. So here at fixed there is no dk, the value is 0. Here at hinge we have to neglect the horizontal deformation and as well as horizontal reaction, so that I am not taking the horizontal reaction here. I am only taking vertical reaction. So again at this joint, one rotation is there, one vertical reaction is there. So vertical will get cancelled. The remaining is only one rotation is there. It can freely rotate. So dk value at in support is 1. So now calculate 0, 3 and 4. So 3 plus 1, 4. So dk value is 4. If we calculate manually, our dk value will come out as 4. When you calculate with the help of this formula, then also we got 4. You can go by this or this, manual or by using the formula. So again at hinge there is only one reaction vertical. So at roller there is only one reaction will take place, that is vertical, and at internal the possibles are 3. Degree of freedom are 3. Here 1, roller is 1. So 1 plus 1 2, 2 plus 1 2 plus 3 5, 5 plus 1 6. So dk at the structure is 6. You can simply calculate. So I will write down here. At roller, so dk is 1. At hinge the dk is 1. At internal our dk, at internal range our dk is 3. At fixed our dk is 0. By seeing this value you can calculate easily. So at fixed our dk is what? 0. At roller, our decay is 1, internal lens our decay is 3, and again roller our decay is 1. So total 1 plus 3 4, 4 plus 1 5. So decay is 5 at this support. So when you calculate with the help of formula, then also we got the 5. So here this is the fixed support. Fixed support as usual, decay value is 0. At internal inch our decay is 3. At inch our decay value is 1. At fixed 0. So 3 plus 1 4. Our decay is 4. So at the fixed support is there on both the sides. The decay 0 at fixed support. Here also 0. 1 inch is there. In support also decay is 1. At roller is the roller also decay is 1. So 1 plus 1 2. Decay is 2. When we calculate with the help of formula, then also 2. This is the structure having both sides fixed support. Decay is 0, here 0, and in there is 3, here 3, here 3. So 3 plus 3 6. Decay is 6. Here also 6 by using the formula. If you look at the structure here at hinge support, our decay value is 1. Here on joint is there. So the at joint, what I have said in my previous video, at any joint, if you take at any joint, the possible of deformation is one is horizontal, one is vertical, one moment is there at any joint. So here they say to neglect the axial deformation, means we are not considering this horizontal force. The how many deformation will remaining? 2. So here at joint the possible deformation, one is vertical, one is moment. So this joint the possible deformation is 2 only, one is rotation and one vertical force. So again at inch there is 3. At internal inch 3. At inch support 1. This is fixed and the degree of freedom is 0. So 1 plus 2 3, 3 plus 3 6, 6 plus 1 7. So decay will come out as 7. Both the answer will same. So this is how we calculate the decay manually. So in exam sometimes they ask to find the degree of freedom by neglecting the axial deformation. That time we have to use this formula. And calculate the by using this formula like this, or you can calculate manual also. If they say to find the degree of freedom with considering the axial deformation, then we have to do by using this formula. This is how we have to calculate the degree of freedom by neglecting the axial deformation. So I hope you all are understood. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.